Hey everybody, and welcome to another Universe Sandbox video. Today I would like to talk about a discovery made by ESO, and it's basically this image. Now what you see in this image is it is a binary system, so a binary star system, these yellow dots with the blue orbits revolving around. Actually these are potentially they are brown dwarfs. And you have a third object, a small planet, revolving this binary system in a polar orbit. Now these systems, they are not rare. A planet that is revolving a binary system, these are called Psychem binary planets. The thing here from this press release from April is that this planet is on a polar orbit. So it is assumed that these kind of configurations are astrodynamically speaking not very stable. But here we are, we found one. And actually in this system there's also a third brown dwarf somewhere far away, 250 AU. But anyway, today in our session I would like to use Universe Sandbox to simulate such a system. Not this system in particular. I put the paper into the description so you can use all the values, but I would like to use Universe Sandbox quite quickly to simulate such a binary system with an polar orbit to see whether it works or not. There's a lot of experimentation, so this is like a small initial configuration or a way how to do it, to show you how to do it so that you have all the building blocks to work on your own configuration. So without further ado, I would suggest let's switch to Universe Sandbox and let's get you motivated to play around with this amazing tool as well. Now we are here in Universe Sandbox in an empty simulation menu. So how did I do this? Well, here in the burger menu, I just simply clicked on New Empty Simulation. So we have nothing. We can turn on the grid and we see that it is completely empty. The simulation, we can pause it for now because there's literally nothing to compute, and we can add our binary system. Now I would suggest that we are using the sun, or let's say two suns. You can also use the brown dwarfs, but I would suggest this is something like a small homework for you where you can extract the data from the paper and see if or how the orbit looks like. You can also play around with the data, also with the masses, and see how it influences this kind of, I would say, almost very unstable configuration. Now these are our two suns in the default setting. Now if we play now, if we start the simulation, let's see what happens. We see that, well, a little bit increasing the speed, that they are moving around each other. Now they are revolving around each other around the barycenter, but you see that they are moving a little bit away, which is pretty annoying. So what we have to do is we click here on the sun, we hold the control key and click on the second sun. So we can, for example, take a look where the barycenter is, and if we play, then you see how the barycenter moves away. So let's click here again. And what we have to do is, well, this setting is pretty useless now, make it a binary system, but well, it was already a binary system. And we can click on something that's called to balancing the momentum. So let's click on this one here. We can click here on our barycenter now, the top view, and now you see how calmly they revolve around each other. So this is like the configuration you have seen in these paper. Let's turn off the grid. Just a very casual, simple binary system minding its own business. Now we can add our planet in some kind of polar configuration. Let's turn on again the grid, and we can zoom in a little bit. Now we have not a top view but an edge view almost, and we can add a planet. Let's call it here the blank planet. So we have here both suns far away, like 0.7 AU almost, more or less. So I would suggest let's go a little bit farther away, 0.5 or something like that. The simulation is stopped. So we can click on the blank planet. We can, for example, adjust the radius a little bit, let's say 0.5. And then we can also adjust the inclination here in the motion tab. So we have to scroll down a little bit, and there we see the inclination. So we can set the value or just use the slider. Let's use the slider, and we are now almost on the perfect polar orbit. Now this looks really crazy. And what we can do now is we can additionally plot the inclination, how it behaves over time. I would also suggest to decrease the simulation speed a little bit, and then let's see what happens. So I don't want to track the blank planet. I would like to stay in the barycenter a little bit, like this. Okay. And we can continue with our simulation. You see the inclination is changing almost immediately, very rapidly. So I don't know how stable the system is that has been discovered by ESO. I assume it's a little bit more stable than this one, but I assume that the stability of such a system really depends on or is very sensitive to the initial parameters, and also on gravitational perturbations and stuff like that. So of course we have here now two sun masses with a large gravitational pull. We have of course a planet that is very close to these suns, so these are not dwarf planets or so. So I can imagine that the gravitational pull has a very severe impact. Now we can increase a little bit the simulation speed, and you see we have our polar orbit. It's oscillating a little bit around this polar configuration, sometimes moving to a retrograde or prograde orbit for a very short period of time. But well, it seems like we are a little bit oscillating around this polar configuration. Now if we take a look from the side view, we see, we can see how this orbit changes slightly, so it's not staying in the perfect elliptical shape, but it's really wobbling around left and to the right, left to the right. So of course, as I always say, simulation Universe Sandbox is not the, let's say, state-of-the-art scientific tool to simulate something, but it's a very, very good one for showing something like that, for simulating stuff, and it's a very, very fair tool to use it for our purpose. Now, oh, this looks a little bit strange. Okay, a little bit overcrowded, but you can see that the orbit remains polar more or less. So we simulate now 0.4 years. We can increase it a little bit and see what happens when we really increase it. Of course, this still remains almost orbit polar, but it slightly shifts to a more ecliptic orbit, it seems. So this is at least our configuration. I strongly suggest to add some planets with different configurations and velocities and see which one is more stable in this configuration. So as always, Universe Sandbox is a very fair tool to use.